All right. Well, you thought last day Mrs. Belanger had problems. Well, today I've got bigger problems. So let's get started right away. Today's word problems are going to be dealing with what we call mixture problems. And with mixture problems, it comes from when you are combining two quantities into a third quantity. So here's an example. Charlotte invested $800, part at 9% per year and the rest at 12% per year. That means she has one batch of money that she puts into one investment and that will earn 9% interest. And then she has another batch of money that she will put into a different investment which will earn 12% per year. So these are your two different quantities and they are going to combine together. After 1 year, the total interest earned was $79.50. So those two combine to make this total amount here. How much did she invest at each rate? Start your solution with your let statements. Well, before we do anything, let's remember our cubes step. C stood for circle the key information. So we know that she invested $800. She did 9% per year for part of it. The rest was at 12% per year. And her total interest earned was $79.50. U stands for underline the question. How much did she invest at each rate? Remember, the U part is what is going to get you to create your let statements. So if we start with so the question is, how much did she invest at each rate? Whatever the question is, that's what your let statements are going to be. How much did she invest at each rate? So she invested some at 9%, she invested some at 12%. So let X represent the amount invested at 9%, and let Y represent the amount invested at 12%. So with these mixture problems, typically the X and the Y represent the two different amounts that are part of the two different mixtures. In a mixture word problem, the first equation will always start X plus Y. So the amount of money invested at 9% plus the amount of money invested at 12%, that totaled $800. So that will always be what you start with, this X plus Y equals, and then this number here just depends on the question. The second equation brings in these percentages. So with interest, what you're doing is you're taking the amount of money that you invest and you multiply it by the interest rate. But your interest rate has to be expressed as a decimal. So 9% is 0.09, 12% is 0.112. So to figure out the amount of interest for this batch of money, it's the interest rate multiplied by how much money you invested. And for this batch of money, it's the interest rate multiplied by how much money you invested. And we know that total is $79.50. So with mixture problems, one of your equations will always start with x plus y, and the second equation, the x and the y are multiplied by your rate or your percentage or whatever it is that is relevant to the question, and then that equals the third quantity. The evaluate stage, now we're going to decide whether we're going to use either substitution or elimination. Some people typically prefer elimination to solve these problems, but with the decimals, some people also decide that they may want to use substitution. They're both set up nicely for elimination because they both have the x and y on the left side and the constant term on the right side. So we're going to solve this problem using the elimination, and what we will do is eliminate the x's. All we would have to do is take the first equation and multiply it by 0.09. If we multiplied the first equation by 0.09, our x's will match. So take a minute and use the elimination method to solve this for x and y. I'm going to press the video. I'm going to get you to solve that using elimination, and when you're finished, press play so that you can check your answer. So do that now, please. Okay, welcome back to the video. Hopefully you found that the y value was 250 and the x value was 550. And since the x represented the amount invested at 9%, your statement at the end, $550, was the sum of money that they invested at 9%. So they took the other chunk of money, which was $250, which is the y value, and invested that in a different place at 12%. If you used question 1 to figure out what your x value was, then you would use equation 2 to do your check, and you found that left side was equal to the right side. So that is the solution. So this is the way you solve a mixture problem. So please take note again that what you circle is what your let statements are. One of your equations always starts x plus y, and the other equation brings in either the percentage or the rate. We're going to move down to question 2. With question 2, just like the last day, you only have to make the let statements and the two equations. You can solve it if you want using substitution or elimination just for practice, but make sure you do the check afterwards to ensure that it's done correctly. So take a look at question 2a. One type of granola has 30% nuts by mass. So kind of like you've got one box of granola and 30% of it is nuts. A second type of granola has 15% nuts. So you've got some other box of granola and it's got 15% nuts. What we're going to do is we're going to mix those two boxes together. Again, a mixture problem. We're going to mix those two boxes together to make a third type of granola that will have 600 grams of granola with 21% nuts. So take a minute, circle your information, and underline what the question is. I'm going to pause the video. Once you've done that, press play on the video to check your answer. Welcome back. Hopefully this is what you circled and this is what you underlined. The underlining is what tells you what your let statement is going to be. What mass of each type? So each type is what your let statement is going to be. So let x represent this, let y represent this. Take a look at example 1 for help. I'm going to pause the video. I want you to make your let statements and then press play on the video again to check your answer. Alright, this is what your let statements should look like. Let x represent the amount of granola with 30% nuts. Let y represent the amount of granola with 15% nuts. Now it's time to make your two equations. Remember, up here, The first equation always starts x plus y equals the total amount. And the second equation brings in your percentages. So 9% of the first quantity plus 12% of the second quantity made the third quantity. So pause the video, try your two equations, then press play again. Alright, here's what your two equations should look like. The first equation, x plus y, so the two amounts of granola should total 600 grams. Second equation is the one that gets a little tricky, and you're probably wondering where this number comes from here. But we have 30% of the first type of granola plus 15% of the second type of granola. And because we are mixing the amount of nuts, it has to equal 21% nuts of the third quantity. So that's 126. So the first equation is relating the amount of granola. The second equation is relating the amount of nuts. So if any of that caused you trouble, make sure you make note of it and ask your teacher in your next class. Take a minute for question B. Circle your information, underline what you're looking for, and make your let statements, please. Pause the video and then press play to come back. Okay, hopefully you took the time to do that, and this is what you should get for your let statements. The question is, how many of each coin does he have? So I decided just for fun to use D for dimes and Q for quarters instead of X and Y, because that's kind of boring. So let D represent the number of dimes, let Q represent the number of quarters. Make sure you're always saying the number of dimes and not just let D represent dimes. All right, make your two equations. Once again, first equation starts with x plus y equals your total, and the second would bring in the percentages. In this case, it's not a percentage, but it's going to be the dollar value of the dimes and quarters. So press pause on the video, try your two equations, and then press play to check your answer. All right, and lastly, this is what your equations should look like. The number of dimes plus the number of quarters is equal to 28, because there's 28 coins. And to bring in the mixture part, it's 10 cents for every dime plus 25 cents for every quarter, and that will total $4.60. Once you've got these equations, just decide if you're going to use substitution or elimination, and then you're good to go. Thanks for watching, and hopefully you'll do well on the practice questions on the next school day. Thanks, bye-bye.